You're listening to and watching Review Recording 1A, B, C to accompany instructional recordings 1A, 1B, and 1C for Section 8.1 of Unit 8, Chapter 8 in Mathematics 2200. We'll do a couple of problems here on solving systems of equations graphically. Example 1. How many points of intersection does this system y equals the negative of x plus 1 squared minus 3 and y equals x plus 1 squared plus q have if q is positive? Let's see if a sketch of the information will help us. The first equation, or the first function, it's a parabola. It has vertex at -1, -3. So let's estimate where that is. -1, -3 right there. And the graph opens down. So the graph opens like this. Notice I'm not being completely accurate, just locating the vertex and direction of opening. Now, in the meantime, we have y equals x plus 1 squared plus q. And we're told that q must be positive. So its vertex is at -1 and some positive value of q. So the vertex is at -1. Well, we don't know where q is exactly, but it could be anywhere up here. So we'll call this, for argument's sake, -1 and q. Perhaps I better move that. There we go. Move it there. Because the graph opens up. And therefore, because the vertex is above the x-axis, there is no way that there can be any points of intersection. So A is our answer. Example 2 asks us to solve the system graphically and verify our solutions. The two graphs will be parabolas, so we need to graph them as accurately as we can. Starting with the first one, we have a vertex at -4 and 3. Now let's also use points -3 and -2. That could be enough. We can always add more if we need more. Putting in -3, -3 plus 4 is 1, squared is 1, times 3/16 is 3/16. So I have 3 and 3/16. Putting in the -2, -2 plus 4 is 2, square root is 4. 4 times 3 is 12. 12/16 would be 3/4. So I've got 3 and 3/4. So I plot those points as I've shown. The axis of symmetry will give me points on the other side. I won't bother to put in my axis of symmetry here. I may need more points than this though. So I'll skip over -1. I'll just go right for the y-intercept at 0. 0 plus 4 is 4, square root is 16. 16 times 3/16 will give us 3. 3 plus 3 will be 6. So I'll plot that point. 0, 6. That is 1, 2, 3, 4 spaces to the right of the vertex. So I'll go 4 spaces to the left for my next point. Oh, put it in the wrong spot. Let's try that again. There we go. Right there. So I think that gives me a reasonably accurate graph for that one. Sketch it in. And let's hope for the best. Next, we start at the vertex for y equals -3x squared, 3/16 x squared plus 6. I'll put in 0. Because 0 is the x-coordinate of the vertex, 6 is the y-coordinate. It also happens to be our y-intercept for that one. So it looks like we right away have one of our points of intersection, if there is any more. Let's go with 1 and 2, put those values in. Y equals -3/16 times 1 squared plus 6. That gives us -3/16, because this is only 1 squared, plus 6. Negative 3/16 plus 6 gives us 5 and 13/16. Substituting in our 2, we've got y equals negative 3/16 times 2 squared plus 6. 2 squared is 4, times negative 3 is negative 12 over 16, has negative 3/4. Take that off of 6, and we get 5 and 1/4. I'll go, instead of using 3, I'll use 4, and here's why. I get negative 3/16. 4 squared will give me 16. So 4 squared will cancel off with the 16, leaving me with negative 3 plus this 6, which gives me 3. So I've plotted those points. 5 and 13/16 is pretty close to 6. Using my axis of symmetry, I got points on the other side of the parabola. So now I can sketch that one. So I have a point of intersection at 0, 6, and here at negative 4, 3. So I have to check those solutions in both original equations. So when I substitute negative 4, 3 in for x and y in the first equation, I've got negative 4 plus 4 is 0 here, so I'm just going to be left with 3 equals 3. So that's good. And when I check it in the second equation, negative 4 squared will be 16. That'll cancel off with this 16 here, so I have negative 3 plus 6 gives me 3. So 3 equals 3 there again. I leave the checks of 0, 6 for you to do. In conclusion, when finding solutions to a system of equations graphically, accuracy is important. Check points of intersection in both original equations. The systems may have no solution, one solution, two solutions, or infinitely many solutions. And you may also want to review instructional recording 1C to see a technology solution for graphing.